As we
Okay.
started to discuss last time, this chapter would look at the tools and techniques that we are going to use in order to control our processes that would enable us again to deliver quality products and services to our customers. And we say that there are two things. We have statistical quality control, where we'll be focusing our quality control on output of the process. And on the other hand, we have statistical process control, where we'll be worried about the inputs. Okay. But basically, these are the things that we worry about. We look at the outputs and control the process. We look at the inputs in order to see their influence on the process. So it goes both ways. Then the other point that we saw was what we mean by a process approach. This is a process approach. We use this process approach in other quality management systems as well. And normally we have input that would be subjected or that would be delivered in order to successfully accomplish the process. And the process would have different procedures underneath, or within the process, we have different procedures. So the input, like raw materials, components, human resource, information, and other things would be used based on that procedure. So the inputs that would influence this process are divided into two. We have controllable inputs and uncontrollable inputs. And finally, through the procedure within the process, we deliver an output. That output is characterized by these quality characteristics. The quality characteristics that we monitor might be one or more than that. And we look at the output and would influence the controllable inputs. So when you are worried about the controllable inputs, we call it statistical process control. As you can see here, we're worried about the inputs for the process. Whereas when we just worry about the quality characteristics of the output, is known as statistical quality control. But they are working for the same thing, enhancing the quality characteristics that we want to improve. Okay, that we want to control and improve. And we also started to see the six problem solving steps. Normally, Montgomery classified them into six, but the Six Sigma DMAIC process classified them into five. But basically, they are doing the same thing. So whenever you want to solve a quality problem within an organization, or for that matter, any problem within an organization, you have to be systematic. Now, these are steps or procedures. They're just delivering you a system in order to systematically address quality problems. So the first thing, identify what you are going to do. And in order to identify, you are going to look at symptoms within the process that are influencing the process. Then you define what you're going to do. So the definition will tell you what is the problem that you are going to address and what are the boundaries within which you are going to work. So these are two important things. Then you go on to investigate. So in order to investigate for the problem upon which you have seen symptoms, those symptoms enable you to define the problem that you are going to address and what are the limits within which you are going to work, or the boundaries. So within those boundaries that are defining the problem, then you are going to collect data. Then that data is going to be analyzed in order to enable you to see what is happening in reality. And basically here, your intention would be to identify the root cause for the problems. Then after that, you are going to go to solve the problem. So you have collected data, you have understood what the problem is using the analyze phase. Then lastly, what would remain is to solve the problem that is causing the symptoms, remember. So you develop different solutions, and the solutions, they are supposed to be innovative. That is very important. So in solving a problem, innovativeness and creativity plays a key role. Then after that, you have the confirmed phase. This phase would enable you to see if the problem is solved. Remember, here you have seen the symptoms and you have defined the problem. Now in the solve phase, you have given a solution. So what did the solution bring to your problem? Is it positive? Is it negative? Or it doesn't have any effect? If it doesn't have any effect, then you are not going to go to the confirm phase because there is nothing to confirm. If it has negative effect, you are going to retract your solution. You are not going to implement. But if it is a positive solution, then you are going to confirm and take it further in your process. So that is what we mean by resolving the symptoms. Now, when the symptoms are avoided or when the problem is solved, then you are going to confirm. Then these stages are normally consolidated as the DMAIC process in Six Sigma. So you can see define, which would take up the identify and define phases together. So you look at symptoms and you define what you are going to do. That's the whole thing. Then you are going to measure, you are going to collect data and see what is happening in the process. And since this is a Six Sigma procedure, then you are going to see the current Sigma level of the process. Then you are going to analyze by collecting different data from the process, and basically you would look at the root cause. What is the root cause? If you know the root cause, then you can easily suggest various alternative solutions. That would be the improve phase. Then in the improve phase, you are going to evaluate your proposal for eliminating the root cause. If you eliminate the root causes, basically we would anticipate that you would improve the performance. Then after that, if you have a positive improvement, you are going to control it. So you are going to institutionalize or take the improvement as one part of the process. That is the overall DMAIC process. And basically, you have seen that the 7 SQC tools are credited to Kaori Ishikawa because he has consolidated them as one statistical control tools package. And these tools are histograms, spreadsheets, cause and effect analysis, flowchart, Pareto, and scatter and control charts. Now, control charts, they're very critical part of the statistical quality control tool. So we'll look them separately in the third chapter, but we'll look at the rest of the chapters this class. Now we also started to look at histograms. So histograms, they'll be telling us how a process is behaving. So they will tell us the shape of, based on the data collected from the process output. Remember, this is the process output, not the input. On the process output, what is the shape of the distribution, what is the central tendency, and variability of the data would be evaluated. So we have also started to look at the benefits of histogram. Normally, once you constructed a histogram, you understand at a glance the variation that exists in the process, and the shape would tell you something about the process, would enable you to understand the process behavior. Then our intention is shape and size of the expression of the data, and if there is something wrong, if the shape and size of the histogram is not normal, then it will just tell you to dig deeper in order to identify what is causing that abnormality. Normally, a normal distribution is, as we said, it has a bell-shaped structure. So if the shape and size is not normal, then we have to dig deeper in order to understand what is causing that abnormality. Then the other thing, if the process is normally distributed, but you have too much reject, then it would direct you to analysis of process capability. We'll look at what we mean by process capability in the subsequent chapter, but basically it would enable you to be concerned about process capability. But if the process is not normal in the first place, you would not go to process capability. That's the whole set. We would look at this assumption when we talk about process capability as well. Then usually, this is the starting point for an improvement process. So the abnormality within the output of the process would tell you something about the process, whether it is uh, something to be concerned about or not. So it would be one symptom, as we said, remember, in these steps, the 6 problem solving steps would be looking at symptoms. So histogram would tell you whether there are symptoms to be worried about or not. So how to construct histograms, I'll not go in depth in here. So we started to look at the phases. So the first thing, collect characteristics data, usually should be 10 up to 100. Then you have to compute the range. That means you identify the highest value and you identify the lowest value, and the difference will give you the range. Then you are going to divide the range using these numbers or 10 multiplication of these numbers. And we would usually want to have a class between 5 and 20. If you have a class, number of classes lower than 5 or higher than 20, then usually they would hide many things underneath. So if you have fewer than 5 classes, then the class width, that means the class width would be, when you look at the bottom of each of the bar chart, for example, if these are the bar charts, let's say, then this would be the width. This is what we call width of the class or class width. So if this class width is very wide, then it would hide many things inside it. So that's not good. If you have too much classes, these are classes. For example, here we have 1, 2, 3 classes. If you have too much classes like this, that means more than 20, then you would have many details, or you might even have some voids in the middle, which would not really be descriptive about the process. So usually what is recommended is that we have 5 to 20 classes. Then the first class, when you choose the boundaries for the first class, this is the lower boundary and this is the upper boundary for the first class. So when you choose the lower boundary of the first class and the highest, the upper boundary of the first class, then you need to make sure that the minimum data value or the lowest value is included in the first class. We don't want this one to be void. So we have to, at least we need to have one data within the first class. That is one thing to be careful about. Then you can use the class width to produce subsequent classes, stopping when we have produced a class that includes the maximum data value. Okay. Then once you construct the histogram, you'll be analyzing the shape of the histogram. So normally we would expect things to be normal like this, a normal distribution, which is something that you expect in your normal process. But if you have abnormalities like these, we have started to talk about this, then you have to be curious as to why these process outputs are behaving like this. So for example, here you have 2 peaks. What does this mean? You have uh, 2 set of operational situations. For example, a very simple one would be some points might be observed during day shift, whereas the other one might be seen at the night shift. So what is really happening? They are supposed to produce the same thing like this normal graph, but you are having 2 uh, peaks. That means there is a behavior on the output, there is something influencing the process in order to making it deliver products in the first or in the second peak. And what are those causes? Why is this happening? Needs to be investigated. So as we said, just by looking at the shape and the size of the histogram, then it will tell you to dig deeper or not. If it is normal, you are not supposed to dig any deeper. But if you have such abnormalities, then that is an indication for you to be worried. And here you have a truncated graph. So when it is truncated, then some values cannot pass beyond this. So you can question why, if they were supposed to pass. So there is something restricting the values to go beyond this. So you'd look at the behavior of the inputs, like the materials, or the machine, the ability of the machine. You might see the capability of the operators or the instruments that they're using, and so on. So whenever you have abnormality in the process, that would be telling you to look deeper into the process. So this is the first thing. This is the only indication that would tell you that to go on with other analysis. But if you have abnormality like the rest, then it is an indication that you need to be worried about the process and dig deeper in order to find the reason why that abnormality is occurring. The next one is check sheet. As you can see from the list, then we have check sheet or tally sheet. Normally, these check sheets are developed just to collect data. That is the first intention. And you can collect data in any way that you desire. However, when you collect data, you need to be systematic. You need to be very critical as to what you are looking for. So for consistency of data collection and for making it systematic, we are going to use the systematically developed check sheet. So check sheet is a form on which quality characteristics that you desire to investigate will be written, and it would make the data collection very simple and consistent, no matter who is collecting the data. And that's the first critical intention of a check sheet. For example, let me just give you an example. Maybe you could tell me something. If I ask you to observe a classroom, then what things you have normally, I hope you have not forgotten how a classroom would look like. So, so could you tell me what you would observe or what could be improved in a classroom? አንድ ክላስሩም ውስጥ ምን ችግሮችን ታያላችሁ? ችግሮችን አንድ ክላስሩም ውስጥ እየሰራችሁ ያው የምትማሩበት ክላስሩም ውስጥ ምን ነገሮች ይሻሻሉ ተባለ? And you are assigned to collect the data. ሞቲ ምንድን ነው ኮሌክት የምታደርገው? ስለምን ዴታ ኮሌክት ታደርጋለህ?
አሁን መጀመሪያ ፕሮብሌሙ ምን ላይ ሪሌት የሆነ አሁን ኤርጎኖሚክስ ከሆነ
በቃ አንድ ክላስሩም ውስጥ
የሰማነው
አንድ ክላስሩም ውስጥ ያሉ ችግሮችን ኮሌክት አድርግ ነው የተባለው።
ኦኬ
ምን ኮሌክት ታደርጋለህ? just feel free.
ኤግዚስት ፕሮብሌሙ ወደ ኳንቲቲ ቀይሬ መሰብሰብ ነው።
ምንድን ነው ኮሌክት ብታደርግ?
ዳታው ነው ሜጀርመንት የሆነው ዳታው።
ምን አይነት ዴታ? ለምሳሌ
ብዙ ክላስ ሰው ከሆነ በጀንደር ላይ ዲፔንድ ሆኜ ይሰብስባለሁ ዳታ ጀንደር ላይ ሪሌት ጀንደር ላይ የሆነው ሪሌት ላይ ዲፔንድ አድርገን ይሰብስባለሁ።
የተሰበሩ ወንበሮች አሉ። የተሰበሩ ወንበሮችን አያለው አልኩኝ። ክላስሩም ውስጥ የተሰበረ ወንበር መኖር የለበትም። ስለዚህ አንደኛው ችግር ብዬ ኮሌክት ማድረገው የተሰበረ ወንበር ነው አልኩኝ። ሌላስ?
ሌላ ደግሞ ቦርድ የተሰበረ ቦርድ ወይም ደግሞ ፕሮፐርሊ ሳፕቴንድ አልተደረገ ቦርድ አለ።
እሺ ሌላስ? ሌሎቻችሁ? አብዱ፣ ጌቱ? ዊንዶው መስኮቱ ትክክል ነው ወይ?
ምሳሌ ሳውንድ ፖሊሽን ካለ ድጋሚ ሶኬት የማይሰሩ ፌል ያደረጉ ሶኬቶች ካሉ ሪከርድ አደርጋለሁ። ሌላ
ቀረ የምትሉት አለ?
መስኮቶች የተሰበሩና ላይት ያስገቡ
ጥሩ
መንገዶችን እሱን ሪከርድ ያደርጋለሁ።
አሁን this is the point. Now we can agree that these are some of the issues. But if I ask you to collect the same data, that means problems within a classroom, then you might come across these 5 points: broken chairs, improper board, windows with broken windows or insufficient lighting. You may say sound pollution. You may say broken sockets. But if you are sent independently, then you might collect 2 of this, 3 of this, or you might include others. For example, you might include broken doors. You might include improper floor. So you can include many things. Now, once you collect the data, when I try to consolidate the data that you have collected about the problem within the classroom, then the data would not be consistent. So in order to avoid that, we develop such type of check sheets. The check sheets are normally required in order to make data collection very organized, no matter who is collecting it. So for example, I would list out all the problems like broken chairs, improper board, broken windows, insufficient lighting, sound pollution, socket, door, floor, and others. Once I list everything, then I'll dispatch you to collect the data based on that check sheet. So you'd look at how many chairs are broken. You'd look at how many boards are improper, how many doors are broken, and so on. So the collected data would be uniform and could be used as one, no matter who is collecting it. And that's the major essence of check sheet. So data collected can be used as an input for other quality control tools. So here, the check sheet does not tell you anything about the process, but rather it would enable you to systematically study the process. So remember the process solving steps. We said you define the problem, then you measure. In measurement, you have to collect data, or in the 6 problem solving steps, we have said investigate by collecting the data from the process. So data collected from the process needs to be systematic, and for that, we are recommended to use well-designed, well-established, and collectively agreed check sheets for consistency and systematic purpose. So the benefits of check sheet, I think we have already covered this. It would make data collection systematic and organized. It would enable us to determine source of the problem. So when you look at the raw data, it might indicate where the problems lie. So you could play with the data once you have collected it. And it would facilitate classification of data or stratification. Depending on the data type that you're going to collect, then it would tell you things to consider as one part, or things that need to be considered as another group or another strata. So based on the data that you have collected, then you might say these problems should be classified into 2, for example, short-term and long-term. This is one example. Or you could stratify it based on the convenience for your target audience. So maybe problem for ordinary students and problem for students with disability. Or you can say for females and male based on gender. So you could create different stratas once you have organized the data. So there is no strict rule to construct a check sheet. The only thing that is needed is to include all the information that you want to collect consistently throughout the data collection procedure. So the first thing, decide what event or problem would be observed. And sometimes it's good to develop operational definition. Operational definition would tell you what we mean by what quality characteristics. For example, what does a scratch mean? When we say scratch, then it needs to be defined operationally. ዝም ብሎ ጭረትን አይደለም። ጭረት ሆኖ ምናልባት በጨርቅ ኦር እንደዚህ ስትነኩት የሚጠፋን ነገር ስክራች ብለን ዲፋይን አናደርገውም። ስለዚህ ስክራች ማለት ምንድን ነው? So it might be considered as an impression on the material or on the surface that cannot be easily removed by a piece of maybe cloth or other things. For example, if you cannot really file it off, then you say that's a scratch. So operationally, what those things mean needs to be defined. For example, what do we mean by broken chair? What do we mean by sound pollution? So sound pollution or is there some level of decibel that we say that there is a sound pollution? So that needs to be defined. If you define that, then the data collection would avoid subjectivity. In order to say that something exists or does not exist, then the data collector would use this operational definition. The other thing that you have to decide in your data collection is to decide when the data would be collected and for how long. This is a matter of sampling. So the data that you collect needs to be well representative of the process. So when will you collect data and for how long? For example, if a production floor has 3 shifts, then you need to represent the 3 shifts. So how many data points will be collected from each of the shifts? And when would that data be collected and for how long? So proper sampling would be important. And the form that you develop or the check sheet that you develop needs to consider this data volume. If you have too much data to be collected, then the check sheets need to accommodate that huge amount of data. Then you have to design the form, set it up so that the data can be recorded simply by putting a tally mark or X mark on the check sheet, and that you have to make sure that data do not have to be recopied for analysis. So you have to make it somehow easy to summarize. ታሊ ያረጋችሁ ሄዳችሁ እንደገና ታሊው መቁጠር አይጠበቅባችሁም። So you have to have a systematic approach in order to do that. Then you have to label all the spaces within the form so that the data collector would know what to collect from where. Then you have to test it. You have to make sure that what you have designed would actually give you what you desire. Then whenever you want to collect that data or whenever a problem occurs, then you use that check sheet in order to collect the data. So this is one example, simple examples. For example, we want to collect data about telephone interruption in our operation. So for that, we have identified some of the reasons. So some of the reasons that we have identified are wrong numbers, information request, or they wanted to talk to the boss. So on Monday, you have collected 12, you have received 12 phone calls, and out of that, 5 were wrong numbers, 5 were directed to the boss, and 2 of them were information requests. Now, how do you collect this data? You'd put this check sheet on the table of the operator or the secretary. Then whenever she receives or he receives a phone call, they would record it to one of these categories. So the first phone call, maybe it was for the boss. So they would put 1 tally mark on the boss cell. Then the first one was information request. So they put another tally mark. Then the third one was wrong number. So they put another one, and then they put another one, and so on. Maybe they requested again for the boss. Then when they reached 5, you can see that I have put 1, 2, 3, 4 tally marks. On the 5th one, you just strike it out. So this is 5. Whenever you see this, it means 5. So here we have 5, 5, 5, 5, 5. So here 5 plus 2, 7, 5, 5 plus 2 again, 7. If they are not striked out, then they are 4 or they are 3 maybe. So they would make it easy to count the number of occurrences in each category or in each day as well. So overall, how many phone calls did we receive in these 5 days? You have it here. How many of them were wrong numbers or information request or both? Then you have it here. How many phone calls did we receive each day? Then you have it here. So it is easy to understand and comprehend the data, and it will direct you to use different tools and techniques afterwards. And here, for example, we have motor assembly check sheet. So who is the data recorder or the data collector? Where was the data collected? And when was the data collected? Then here you have, again, from Sunday up to Saturday, you have 7 days, and you have defect types that occurred in the motor assembly station. So there are different defects that are observed. Okay, then you just count each of the defects that you observe on Monday, Tuesday, Wednesday, and so on. But one thing that is confusing now, you can compare the first check sheet and this one. Now, how many rusted parts were supplied on Monday? Now, parts that were rusted and supplied on Monday are placed here. Now, in order to count this, you have to be very, very careful. 1, 2, 3, 4, 5, 6, 7, 8, 9. So imagine if there are 20 or even 30, then counting this would be very, very confusing. That's why we suggest that you use this type of tally mark manipulation or designation, sorry. So here you can strike out this as 5, then this one would be eliminated, so you have 9. It would be very easy. Now, if this is 5, then you could strike it, and easily this would be seen as 5. So using this principle for tally sheet, tally marking is very recommended. Then again, you have total for each of the defects and each of the dates. So you could use this data for further analysis and understanding. The other type of tool that we are going to see is the cause and effect analysis. So cause and effect analysis is used in order to understand what is happening underneath the occurrence of some effect. So the effect might be defect, or it might be a problem or a challenge, and sometimes even it might be a positive thing. You want to achieve something. So what are the reasons that would enable us to achieve that positive thing could be analyzed. So once defects are identified, or defects, problems, challenge, and so on, it's not mandatory that they are only defects. But whenever there is something that you want to investigate, we call them effects in general. So when you want to investigate the probable cause of the effect, then you go on identifying what are the possible causes. And the cause and effect analysis would give you a frame within which you could identify those probable causes. So this diagram, or cause and effect diagram, is a tool that helps the quality manager or anyone who is interested to solve the problem to identify, sort, and display the various causes for the problem or for the challenge, or even for any quality characteristics. And when you develop this diagram, the diagram is a very clear illustration of the relationship between a given outcome or effect. Outcome or effect would be the problem or quality characteristics or the challenge. So you have the effect. So what is the relationship between this effect and the various factors, all the factors that would influence it. It doesn't matter whether they are the ones who are influencing it now or not. We have to list out all the possible factors or all the possible causes for that problem. And the reason why we are interested about identifying the root cause for any problem is that it would help us to determine what is happening in that problem or in that quality characteristics. And when you develop this, remember we said we are worried about all the factors. Since we are worried about all the factors, then we cannot do it alone. It should be done in a group participation. So people who are directly involved in that process or who are encountering that problem or that challenge or who are realizing that the defect need to participate in that group. But not only those people, but other people who have some say in the process need to be included in the group for this cause and effect analysis as well. And once you develop it, normally it is very easy to understand. So its development need to be, the development of cause and effect analysis need to be critically seen. But once you develop it, it could be understood by anyone. It could be understood by anyone in the shop floor, and it would directly be, it could be comprehended for their involvement as well. It would indicate possible causes of variation in the process. And since it is a group work, then it would increase knowledge about the process. And everyone would know how their process or how their activity would impact this effect or this problem. And another thing, it would, once you scrutinize all the causes, then it would direct you to identify areas where further data should be collected for the study. So again, in the investigation phase, the root cause analysis or cause and effect analysis would enable you to see where and what type of data is required to understand the problem further. So what are the procedures? First, you have to define the problem or the effect that you want to analyze. So remember, in the 6 problem steps, we have already defined this. Or in the measurement phase, you have to define what you are going to measure. Then perform the analysis in teams. And the point would be to uncover potential causes, not the actual causes, but any potential cause through brainstorming. Then you draw the effect box. We'll look at this later on. Then you identify major causes. Then you go on for possible causes. And then you order the causes to identify those that seem most likely to impact the problem. Then again, lastly, you would analyze, design, measure, and take corrective action. So we can see it on this one. Let's stop here for now.